Lesson for today is blockwork system. Blockwork system is basically a building construction method which uses cement block masonry unit as the main materials to form walls either load-bearing or non-load bearing. Blocks are larger compared to any standard bricks. Blockwork is reinforced with steel bar, laid and bonded with other units using mortar. Blocks are available in a variety of sizes, densities and shapes to suit different needs and applications. Blocks are popular alternative to bricks due to the conveniences and cost effectiveness. The raw materials used to manufacture blocks are basically cement, aggregate, water and admixtures. Blocks are manufactured using steel mold. Some advantages of using blocks are highly durable, low maintenance, fire resistance, economical, provide thermal insulation, work can be paused and resumed as required, and does not require foam work at site. Standard dimensions for block are as the following. Number 1. Typical block equivalent surface area of 6 bricks. Number 2. The length is varying from 190 mm to 390 mm. Number 3. The width is varying from 90 mm to 190 mm. Number 4. The thickness is varying from 90 mm to 190 mm. Number 5. The weight ranging from 6 kg to more than 15 kg. Number 6. Blocks are manufactured to meet compressive strength standards between 7 Newton per millimeter square to 20 Newton per millimeter square. Number 7. They are produced in solid and hollow. And number 8. Hollow block can be embedded with insulating materials or concrete in the void. Block comes in a wide variety of size and type used within the construction industry today. Basically, there are two classifications of blocks. Number 1, solid block without any forms or voids. Number 2, hollow block with one or more form or void. Solid blocks are commonly used, which is heavy in weight and manufactured from dense aggregate. They are very strong and provide good stability to the structure. So, for large work of masonry, like for load-bearing walls, these solid blocks are preferable. They are available in large sizes compared to bricks, so it takes less time to construct concrete masonry than brick masonry. Hollow concrete blocks contains void area greater than 25% of gross area. Solid area of hollow bricks should be more than 50%. The hollow part may be divided into several components. They are manufactured from lightweight aggregates. They are lightweight blocks and easy to install. Type of block selected for a particular application will depend on factors such as number 1, density, which will determine the weight of the block. Number 2, load-bearing characteristic, whether the block is going to carry load or not. Number 3, appearance. This depends on the designs of the buildings. Number 4, weight, and handling. However, this depends on the density of the block. And number 5, thermal characteristic, whether the block is required to control the thermal conductivity. Blocks are available in a range of densities. Blocks that are light in weight are usually less dense because they are made from an aerated mix. The heavier blocks are normally denser. Concrete blocks are classified by their compressive strength. This is their ability to withstand compressions before showing any signs of fatigue. Block is considered dense when compressive strength is between 1,850 kg per meter square to 2,100 kg per meter square. And block is considered lightweight when compressive strength is between 1,000 kg per meter square to 1,500 kg per meter square. Block is considered super lightweight when compressive strength between 850 kg per meter square to 1,000 kg per meter square. Blocks are produced in a range of shapes and sizes. The face side is usually 450 mm by 225 mm. The thickness varies from 60 mm up to 150 mm, and the weight varies from 6.3 to 15 kg. They are produced in solid, hollow, and multi-cut format. Multi-cut enable a bolster cut to be made without wastage. Walling built with precast blocks may be divided into two main categories. Number 1, load bearing, and number 2, non-load bearing. The blocks are precast in molds and compacted with the aid of vibrations or molding machines involving the use of compressed air or a combination of both. These blocks are usually made of concrete comprised of cement and aggregate. The cement used is usually Portland cement, and a variety of aggregates are used. The advantages of load-bearing blockworks are: number 1, greater strength due to solid microstructure. Number 2, cheaper than lightweight blocks due to the manufacturing process. However, there are disadvantages such as: number 1, it's a typical solid block without any aesthetic elements. And number 2, it is heavy to handle and difficult to cut due to solid and dense profile. Non-load bearing blockwork. These are also precast in molds. However, they are blocks produced in slab size format and then cut to the size required when set. These blocks are usually made with a variety of lightweight materials and cement, such as brick or clinker with coke or ash and cement. The advantages of non-load bearing blockworks are: number 1, easy to handle, can be cut, drilled, and chased easily. Number 2, good heat insulation due to void that trap air. Number 3, reduce the load on foundations due to lightweight. However, there are disadvantages as well, such as: number 1, it absorbs a lot of moisture due to porosity. And number 2, it is easily broken by careless handling because the block is less solid. These blocks are made from lightweight or low-density materials such as fuel ash, clinker, or lightweight aggregates bonded together with cement. They are easy to lift and handle and have good thermal and sound properties. They can absorb water and are be easily broken during handling and construction. These are the typical standard size for lightweight block and solid dense concrete block. This is an example of dense concrete block. The size can be varies in width ranging from 100 mm, 150 mm, and 225 mm. Normally used for load bearing and exposed work in industrial buildings. This is an example of lightweight block. The size can be varies in width ranging from 75 mm, 100 mm, 150 mm, and 200 mm. Normally used as lightweight internal partition. This is an example of cellular block. The size can be varies in width ranging from 75 mm, 100 mm, and 150 mm. Normally used as lightweight partition but not limited to. This is an example of hollow block. The size is 440 mm long by 215 mm wide and 215 mm deep. Normally used for load-bearing and hard-bearing walls in industrial buildings. During the manufacturing of blocks, there are four basic processes. Number 1, mixing. Number 2, molding. Number 3, curing. And number 4, cubing and storage. Cement, aggregate, water, and admixtures are the materials used in the manufacture of concrete blocks. To manufacture concrete blocks with specific properties, the type and ratio of each material is altered according to the mixture proportion. First, mixing. This requires certain quantities of aggregates and measured in weight batcher plant. They are later dumped into a conveyor belt. The conveyor then moves the material to mixer where water is added as the aggregates and concrete are poured in. The water is also precisely controlled with the electronic measuring system. Any additional admixture are then added and the batch is mixed for 6 to 8 minutes. Second, molding. The concrete is moved using conveyor belt to block machine which mold is set up for a specific type of concrete block. Next, the concrete are fed into the mold at a measured flow rate and the vibration time and force are accurately controlled. After proper compressions and consolidation are attained, the block is removed out of the mold onto a flat steel pallet. Third, curing. Steel pallets are then shifted to an automated stacker which places them into low-pressure steam kilns to be heated. Generally, the rack of concrete block is preset in the kiln. Steam is gradually introduced to the kiln and the temperature is slowly increased to the appropriate level. Shut off heat and steam when maximum temperature is reached and soak blocks for 10 to 18 hours in the hot, moist air. The moist air is exhausted out of the kiln where temperature increases to dry the block. Curing continues for 16 to 24 hours at high humidity and an average temperature. Finally, cubing and storing. After curing process completed, block is rolled out of the kiln. Each block is then unstacked and placed on a chain conveyor. Blocks are then moved on to cubing system, which stacks the block on a wood pallet by aligning and stacking to form a cube of 4 blocks across by 3 blocks deep and 6 blocks high. The cube is wrapped in plastic for security and protection from the elements. The following is the typical installation process of blockwork. First, mark the layout of the proposed block wall. Second, build the formwork for footing and continue with concreting. Third, calculate to estimate the quantity required for block and mortar. Fourth, prepare setting out for block position. Fifth, mixing and ration of mortar to join the block. Sixth, begin lay the block, start with the corner, then continue for the rest. Seventh, regularly check the alignment during laying of the blocks. Eighth, apply mortar and continue further with laying. Ninth, during laying, add the reinforcement where necessary according to the specification and design to strengthen the wall. Blockwork system also has its advantages and disadvantages. The advantages of blockwork system. Number 1. Cost saving. Does not require high initial cost. The usage of costly and time-consuming plasterworks can be eliminated. Number 2. Speed of construction. Concrete block is prefabricated off-site and only require erection on-site. Number 3. Durability. Can withstand severe weather and temperature. Last for centuries if well maintained and literally require less maintenance. Number 4. Fire resistance. Functioning as firewall between rooms or structures. Number 5. Insulation. When the weather is cold, it will keep heat in the house. It keeps a home cold when the weather at outside is hot. Sound insulation can also be provided. Number 6. Environmental friendly. It's prefabricated off-site, therefore reduce construction wastage. Blockwork system has disadvantages as well, such as number 1, appearance. It's commonly plain and unappealing. Number 2, material and transportation costs. The price of concrete regularly fluctuates and vary depend on regions. Transporting prefabricated blocks require high temporary fee. Number 3, construction speed. Mortar need time to fully dry out between blockwork, thus this consumes time. Number 4, relatively new technology to construction industry and trainings are required for labor. This is the typical bonding arrangement for blockwork system. And this is the alternative methods of bonding a queen. Many manufacturers provide special blocks that assist in the bonding to prevent wastage from cutting. These blocks ranging from half, quarter, and three-quarter blocks. Other special blocks include return and reveal blocks, which used to close cavity at door and window opening. To maintain bond within a wall, it may be necessary to use either coursing bricks or blocks. These can be cut from a whole block or special blocks manufactured to those sizes. These blocks are built into the walling adjunctions and over opening in the wall. Apart from the size of the blocks, the building operation used to erect the walls are the same as brickwork. Basically, there are 10 blocks per square meter as opposed to 60 bricks per square meter. Blocks are usually delivered on pallets and should be stored on a hard level base or on battens on drained, even ground. Blocks must not be tipped or rough-handled. Move blocks in packs by mechanical means, stacking no more than 2 pallets high. Take good care when moving and stacking blocks ready for use. Load blocks up to just above 2 block courses in height. Stack as close to the work where possible. Never mix different types of blocks in the same run of walling. And do not use common or facing bricks as closures, as they will reduce the thermal and sound insulation qualities of the blockwork. It is not always convenient to build a junction wall at the same time as the main wall. The junctions are normally bonded, or ties can be used with a straight joint. Indents may be left to allow bonding to occur at a later stage. Indents are the gaps where blocks will be inserted at a later date. Bonding should be set out so that lintels sit preferably on a whole block. And if this is not possible, a minimum 2/3 length block is acceptable, but definitely not less, normally by at least 150 mm. Case Study 1. The Z Residence at Bukit Jalil. This is the example of a high-rise building using interlocking blockwork system for its wall. This is the details for the particular projects. A condominium built on 7 acres of land with 4 numbers of blocks. The IBS system used is the blockwork system. This is the manufacturer for the blocks. It is Proven Holdings in Berhad. This is the type of block used. It is called the interlocking engineering blocks. The block has special tongue and groove features to facilitate installation with void to provide heat and sound insulation. Case Study 2. One city at USJ 25. Again, this is the example of a high-rise building using lightweight blockwork system for its wall. This is the detail for the particular projects. It is a mixed development project, and the IBS system used is the autoclave aerated blockwork system, or called AAC. Broco Industries is the manufacturer for the blocks. AAC block is made of cement, lime, fine aggregates, gypsum, and water. The blocks were put into autoclave machine for curing process. In the autoclave, the blocks were applied with high pressure of steam to accelerate the curing and produce higher strength of materials. This is the type of AAC block used for the particular project. This is the typical step to manufacture the AAC blocks. The characteristic of AAC blocks such as number 1, fire resistance. The blocks can hold fire for a duration of 260 minutes or equivalent to 4 hours. Number 2, lightweight. It is lighter than any conventional brick at 490 kg per meter cube. Number 3, heat reduction. It provides natural protection against heat. Number 4, noise reduction. The blocks provide good sound insulation. However, AAC block has limitations as well, such as number 1, high water absorption due to porosity in the microstructure of the blocks. Number 2, it needs to handle with care due to brittle. For high-rise building, material lift or hoist may be required to bring the blocks to the upper level. Each fixed block should be checked for its line, level, and plumb. Lay mortar for full bed width and for a length of 3 blocks at a time. Lay 1 block at a time and gently pressing it in the mortar bed. Use 12 mm thick plywood piece to ensure uniform vertical joints. Excess mortar coming out on the edge while pressing block in position in bed mortar to be taken by trowel and reused. Use straight edge or spirit level on top of the blocks laid and check the top level. Make sure that the spirit level is in working condition and read the bubble carefully. Lay the last closure block in the course to close the bond and locate it to be near the center of the wall normally. Also perform check for horizontal level, surface even, and right angle. Perform checking using a checklist for record purposes and certified by person authorized. Do not practice such activities. Number 1, throw cut block in debris. Number 2, use block as platform. Number 3, use block as scaffold. Do not leave materials unused, and level of all interconnected should be at the same level. Whenever walls left incomplete for whatever reason, left it in staggered. Keep the site clean. Do not forget components such as lintels, and do not let block used by someone not supposed to. That's all for the lesson this time, and thank you very much.